It's Sunday, March 27th. My name's Juan Brown. You're watching the Blanco Lirio channel from the New York satellite office of the Blanco Lirio channel. By now, everybody's seen the tragic helicopter crash of the R-44 Cadet near Rowlett, Texas, where the tail boom was completely severed from the helicopter, killing both on board. I'm getting a lot of questions about this crash, and though I'm not a helicopter rated pilot, I've reached out to several helicopter professionals that have helped shed some light on this, and I've got a lot of information to share with you on it. From WFAA TV in Texas, we now have a picture of the tail boom being picked up by the NTSB investigators, showing clearly that the tail boom was severed by the main rotor of the helicopter. The question is how did the main rotor come in contact with the tail boom and chop it off? Preliminary reports indicate that the two pilots on board was conducting a training flight. There was a fairly new helicopter, CFI, with about 1 month's experience, and she was training a fixed-wing private pilot in order to get his helicopter add-on rating. At the time of the accident, ADS-B data indicates that they were hovering, practicing hovering, doing some maneuvers while hovering when the accident occurred. The rotor system on the Robinson series of helicopters is a two-bladed, semi-rigid, underslung, teeter-totter rotor system, which works something like this. The black part being the mast, my fingertips being the teetering hinge, my wrists being the two coning hinges, and my arms represent the helicopter blades. So normally when you move the cyclic control of the helicopter, you can fly the helicopter around like this. But if you do an extreme abrupt control input, you can do something called bump the mast, like that. Exceed the design limit of the rotor system. Now, if you reach up to a R-44 helicopter blade on the ground, first you'll notice it's fairly flexible. And if you were to gently pull that blade down, you would be unable to reach the boom of the helicopter with that blade. The mast stop would stop the blade from touching the boom. But if in the event that you hit a hard enough control input and bump the mast hard enough, you can flex that blade down into contacting the boom. To exacerbate this problem is if you're practicing, this mast bumping is typically associated with a light G, low G maneuvers, like popping over a hill or something like that. But also, too, while hovering the aircraft, one of the maneuvers you got to practice prior to solo, helicopter guys, correct me if I'm wrong, is vortex ring state escape maneuvers, if you will. How to get out of a vortex ring state. So you get the helicopter hovering, get it to a point where the vortices, the wingtip vortices, are pouring back down into the top of the rotor disc, thus stalling the inner part of the rotor disc, and the helicopter begins to settle, begins to descend. If you pull more collective to try to recover, that exacerbates the situation. So there's two basic techniques to recover from this that you need to practice. One is flying the aircraft forward or doing a little sidestep maneuver to the side. Either of these are delicate maneuvers and require gentle control inputs. And in the Robinson helicopter, or in any helicopter, a thing that can exacerbate this situation is if the rotor RPM gets low, begins to decay a little bit, even if it's within limits. If the blade RPM slows down, the blades will begin to cone more, and as the blades cone more, they become more flexible, thus more prone to hitting the tail boom in the event of a mast bump. Robinson helicopters are some of the most widely produced helicopters in the world today. They are used extensively in training. They are frequently involved in training accidents and thus tend to get a bad reputation. But often it's found that the aircraft is being operated outside of the design limitations of the aircraft. And now we have this massive pilot shortage where we're getting brand new pilots teaching brand new pilots how to teach brand new pilots. And we're getting to a point where how do we safely pass on this knowledge to a whole new generation of pilots and at the same time continue to operate within the design limitations of our aircraft? Thanks so much for your support of this channel, especially the folks over on Patreon. We'll see you here.